Hello. Here in this problem, we will relate linear velocity to the diameter of a pulley, right? In application problems, you have seen how we have found satellite distances on the earth, and this time is distance on the pulley, the machine which we use, okay? And this is all because of our understanding of degrees in radians and angular velocity, right? Now here is the problem. Find the diameter of a pulley which is driven at 720 RPM by a belt moving at 15 meters per second. So this is most of the cases you see pulleys being driven by motors, right? So this is a practical case and always to be seen, right? So what is happening here? This is my pulley, right? So it is being driven by a belt. Let's say this is my belt. It says it moves. The belt is moving at 15 meters per second. Let's try to understand. Let's say we have this point. So this point moves on the belt at the rate of 15 meters in 1 second. So if we say how much will the belt move in 1 second, it will be 15 meters. Do you understand? So when we say linear velocity here is 15 meters per second, understand like this. We say linear velocity equals to 15 meters per second. It means in 1 second, right, it moves 15 meters. Does it make sense? So in 1 second it moves 15 meters, correct? Now if a point here moves 15 meters in 1 second, then a point here circularly moves how much distance? And both should be same, right? Because this point is translated at this point on the belt, but this point was also there on your pulley, right? So in 1 second it moves some distance here also, correct? And both should be same. So that is how we are going to relate linear with angular. Do you see a sector being formed here? Now this sector shows the movement of a point on the wheel, right? Let's say there are 2 points here. One went on the belt and the other kept itself on the pulley, right? But in a given time of 1 second, both have moved through the same distance, correct? Yeah. Now let's look into this part. And it says diameter of the pulley is to be found when it's driven at 720 revolutions per minute. So it goes through 720 revolutions per minute. Now 720 revolutions per minute, we should convert that to radians, right? So that we know arc is, this length is, we know r from here, and if we know theta, we know this a, and the relation is, that's a good place to start our relation. Again the same triangle, right? So we'll make our triangle here, and we say, well, here is our triangle, and in this triangle, this is a is r theta, right? So a is r theta. So I have to find r, but I know a this time. A is 15 meters in 1 second. Do you see that? And theta will find from the given RPM. So you understand our approach now. Okay. So 720 revolutions per minute, in 1 revolution it will do 2 pi radians. Is that okay? Now, and in 1 second it will be divided by 60. So we can say this as 720 times 2 pi radians, right? In a minute, right? This is in a minute. So in a minute, correct. So how much radians or theta in a second? Let's do that. So we say, let's put theta here in 1 second. So let's say in 1 minute is this much. So in 1 second, what is theta in radians? So we'll divide this by 60, correct? So you get 720 times 2 pi divided by 60. That gives us the angle theta in 1 second. Is it okay? So we can simplify this, correct? So 726 goes 6 times 1 is 6, 12, and 12 times 2 is 24. So we are left with 24 pi radians. Do you understand now? So 24 pi radians in 1 second. That is what theta is. So theta for us is, when we don't write any unit, it means radians. Radians, as you know, is a ratio of a over theta, right? So both are in units of length, which cancel out. So radian basically, I should say a over r here, this side. So theta is ratio of length units. So when they cancel out, we don't really have a unit, but we call it radian, okay? So let me write this as 24 pi, correct? Now this 24 pi is my theta. And how much will be the distance covered? A? A will be equals to r times theta, which is r times 24 pi, correct? Now, as you know, the circular distance covered is same as the linear distance covered in 1 second. So we are talking about, so we are equating these 2 seconds in 1 second and this also in 1 second, correct? So when you equate this, you get 15 equals to 24 times pi times r. And now from here, you can find r, correct? So we say r equals to 15 divided by 24 times pi. So that is what we get of our radius, right? And diameter will be twice this, correct? So we can calculate this answer here and we say 15 divided by 24 equals to something, and then divided by pi equals to 0.198. Okay. Let me write 0.2, right? It is 0.1989. Okay. So we'll write, or we'll use it. So the diameter we are finding is, so diameter is what? Diameter is 2 times r. Is it okay? Diameter will be this much, correct? That is diameter, right? 2 times r. So let's assume this be 0.2. So 2 times 0.198, OHS, let's say 0.2, right? 0.4 meters, correct? Because this is in meters. Is that okay? So that is our answer, 0.4 meters. Do you understand? So that is how we can find diameter of the pulley, right? If you want to put it in centimeters, you can always multiply by 100 and then write your answer, correct? So we say, or so we can say the diameter of the pulley is approximately 0.4 times 100, which is 40 centimeter, correct? So that's your answer. I hope you understand and appreciate the method we adopted. We equated distance moved linearly and distance moved along a circular path in 1 second. Both should be same, and got our answer, correct? That's how you should be doing it. Thank you.